Welcome back. So, we will start second part of this lecture. I hope you have understood what is AI, right, because this is something which many people always ask this question. If you ask a children also, they will be telling you the meaning of AI, but may not understand. AI stands for artificial intelligence. Human have natural intelligence. So, AI obviously is something which related to the mimicking of human intelligence. As we told about that, it is the ability of machines and computers to mimic human mind decision making process as well as problem solving capability, and that is what is AI. And as a part of AI, we are going to learn machine learning and deep learning. Machine learning deals with structured data, deep learning deals with unstructured data. So, therefore, in the machine learning process, machine can automatically learn from existing data and give predictions, but nonetheless you need some human intervention. So, we talk about these aspects. The AI actually can do like human, they can think like human, but whether they can think rationally like a human or not, that will be decided by the intelligence level of the artificial machines. And after thinking, can they act like a human, can they act like rationally like a human or not. These are the two important features of AI, which is one is the thought, other one is the behavioral aspects. So, let us now look at how we can go ahead. This is something where I talk about it. Before that, let me also tell you there are 4 important cognitive tasks a AI system must do. First, they should understand the natural language processing to communicate with human, otherwise how they will communicate with human. They cannot use sign language, right, they have to use some kind of a language, and we have many natural languages. That is why you should understand whether natural language processing can be built in, and that is what is called NLP in machine learning, very important part of the machine learning. Second important is that whether it can store information effectively and efficiently, that is called knowledge representation. Like we can do it in our brain, right, we can store information effectively and then efficiently use that. After we have information, can we retrieve the information, answer any question or not, that is called automated reasoning, AR many cases, and this we can call KR. As you can see, KR, AR very important, because that is all tells you knowledge representation and automated reasoning. And last thing is the machine learning, can we adapt to a new circumstances by learning from the previous experiences. This is called ML. It can be DL also, deep learning, but at the beginning it is ML. But what are the key features of AI? And any AI system must have 4 important features, as you understand. First, you think about yourself. First, you should observe. Observation is most important. Whenever we are trying to understand anything, first you observe very keenly and think about what are things happening. That is called observation. That is a very important characteristics feature of AI system. Second, analytical ability. Can it analytically analyze the observations, whatever is taking place. So, that is very important, analytical ability. And third, which is very important, is the problem solving ability. Can it solve the problems given all these aspects, observation, analytical ability, can it solve a new problem or not, that is very important. And obviously, key important aspect is in all these things from observation to problem solving is the learning. The learning is what is important. You have to make the machine learn particular aspects, then only it can solve the problem. So, these are the 4 key features of AI. Now, AI has 2 parts, what is called narrow AI and general AI. What is narrow AI? Detecting faces, right. In the airports sometimes there will be cameras, and nowadays actually you can have what is called Digijatra. They can detect from your using your face that you are the particular person traveling or not. That is a very important AI tool. Plugging content online means you are using all kinds of social media. Whenever you are putting content online, you are using specific AI tools very easily. Whether you want to upload some videos, upload some photos or write some text, you could see automatically the text will flow, or many things will be coming automatically. These are all AI. or very simple customer care inquiry. Whenever you call, many times you do not realize other side of your call the computer is answering, it is not a human. So, because there are various standard questions that computer can answer, that is basically also AI. Or we all use online chatbots, right, even in mobile phones or computers. These are all part of narrow AI, very routinely used, I will say. So, we are using AIs for in our day to day life. That is what is called narrow AI. Okay. You remember this term narrow, that means we are not utilizing full artificial intelligence, that is why it is called narrow. What is generalized AI or general AI? It remains a concept till today. Wants to do, it is envisioned to be adaptable and reasonable as human intelligence. What it means to say, the day computer can do everything without human intervention, think like a human, think reasonably like a human and act rationally and reasonably like a human, that day role of human is going to be over, looks like. Many people call it a doomsday, but I will not say that, because we will have some control on the computers. You could see some movies available on the many of the stores about these kind of aspects, that whether the day computers will achieve human intelligence, what will happen to the whole world. So, that is the generalized AI which is not yet achieved, do not worry about it, and it is not to be achieved in very soon also. Very simple application of AI as speech recognition. Okay, all of you probably use this tool. You can easily recognize a speech by using AI tools. Customer service, I already told about it. Whenever you are making a call to customer service, whether your call is answered by a computer or answered by a human, that is something always will be there. Many times the voice will look like a human, but answer is given by computer. Third important thing is the computer vision. Can computer read a picture? That is called a computer vision. Can you extract data from these pictures and make some justification? Third one, recommendation engines. You know, many times you need to write some recommendation letter for jobs, or you have to get some recommendation letter for jobs from your professors, from your superiors. So, can you automate it? Actually, many of the universities have already done it automated using AI tools. Very simply it can be done, and you could probably see that also. Sometimes if these recommendation letters are not submitted in time, you will get a reminder, again it is automated by using AI tools. Stock market trading, it can be also done automated. In fact, in today's world it is automated. So, these are already there as an application of AI in the market. Well, is AI a game changer? That is what everybody talks about it. You know, we have a lot of courses on AI ML, even in India, abroad, everywhere. So, question is it so? As far as the data available in the literature is from UN websites, AI potential contribution to global economy will be $15.7 trillion. That is massive. In another 5-6 years time, it will be about $15.7 trillion economy will be controlled by the AI. And you know, it will boost the GDP of any local economics up to 26%. GDP is gross domestic product, that is an indicator of economic growth, that is what it is. And what are the beneficiaries? It says China and North America will be the most important beneficiaries. China will see almost 26% boost of GDP, and North America will see about 14.5% GDP by 2020. It is almost over, right? 2020 is 4 years back. So, now the question is, we as India, where do we place? Yes, we are moving towards that directions. Everybody is talking about using artificial intelligence as a important feature for all our operations, whether it is in the airports or in the railway stations or even customer care, everywhere. So, it is going to grow faster and faster, you can see that. So, now the second question important is, why AI is important in materials engineering, because that is what we are going to learn in this course. Is it so important? To understand that, we have to little bit know how materials were discovered, and that is what you should focus very clearly. I am talking about 4000 BC to about 2010. I can talk about 2020 also, but I am not doing it, because 2010 is hardly about 10-15 years ago. So, which you know what has happened. So, you may be at the time 10 to 15 years old, maybe like that. So, you will have some idea about it. So, what happened before 4000 years ago? Let us say about Stone Age or before that. In Stone Age, human used to make all these gadgets to kill animals using stone. That is why it is called a stone age. We have nothing, everything was available on the earth crust as if, because it was abundant for the human, and that is what has been done. So, there is no material was discovered, because everything was available naturally, whatever required. Sand was available, stone was available, fire was available, some metals like gold, silver were available. So, humans were happy with that. And then came the potteries. Pottery is a major discovery, right? Why? Because you need to make pots where you can cook foods, you can keep water. So, pottery was discovered. Pottery is basically coming from clay. Clay is used to make the green pottery, and then green pottery is fired to get a strong potteries, right? That is what it is. So, that is one of the major discoveries of human other than fire in the early days of our existence on this world. So, about 4000 years ago, 4000 to 5000 years I will say, in that time period, nothing is clear, we have the use of metals, swords, the major ammunition in those days, swords or all kinds of harpoons, everything was done in those days, and it was made by bronze. Remember, bronze is the first alloy made. Bronze is the alloy of copper and tin. It was accidentally discovered. It was not made by human. It was accidentally discovered. Probably someone was trying to mix them together unknowingly, and it accidentally discovered. That is what is documented, and that is how the bronze age started, and everything was made of bronzes. And finally, around 2000 about 2000 BC, you have this iron age, where instruments or the swords and other things were made from iron and steels. Okay? And then beyond that, we have all kinds of things. We have steels, you can see that concrete structure, steels, everything, and super alloys. Many more discoveries were done in last 200 years, within last 200 years. Okay? That is what has happened. And finally, we are in silicon age now. In this time period, silicon is very important, because all our devices are basically made on silicon crystals, whether it is a computer, tablets, mobile phones, everything. And we have Google, Facebook, what not, okay, Instagram, and many things. I am cannot describe all of them. So, that is what it is. This is in a nutshell, the materials are discovered. But remember, silicon is very important material for the discovery of computers. Without that, it is not possible. Along with silicon, there are many things, insulators, okay, conductors, many other things are required. So, every part of our life, material is important, whether today or 1000 years ago or 5000 years ago or 1000 years ahead, you cannot deny the material will not be important. Material will be important every part of life. So, that is why materials engineering or discovery of new materials to trigger changes in the society is what is the key aspects in design of new materials, and that is what we learn in materials engineering. And here, whether AI can help it or not. Okay, this is a chart taken from Michael Ashby's book, Design and Selection of Materials, 10,000 BC, you can see, to about 2020. Yes, now I want 2020, correct. What is it? It says relative abundance or importance of the materials. So, what do you see? At the beginning, gold was primary important, it is freely available. Copper was also. Then slowly the alloys came, bronze, iron, cast iron steels, alloy steels, they are very important, primary important. Finally, the titanium alloys, everything else came, aluminum alloys, you can see that slowly how this, but importance of metals have decreased over the time, correct, great importance, but still it retains its primary importance compared to others. Compared to the ceramics and glasses, initially stones, flint, potteries, two liquid potteries, pottery was discovered from clay, then came glass, glass was also serendipitously discovered, and then came cement, refractories, fused silica, and all kinds of things, tough ceramics like alumina, silicon nitride or PSZ, whatever you say, all these things become very important over the time scale I am talking about it, 10,000 BC 2020, that means 12,000 years, that is what happens. And composites came much later, obviously. Initially we know there are natural composites like a straw brick. Straw brick is basically natural composite. Human used to make houses using straw brick. Okay, you add straw into the clay and make brick. That is how the mud houses are made in the villages. That is a natural composite. Bamboo, wood is a natural composite. Okay, paper is also a composite, remember that. But then there is a huge gap. Then in the latter part after 1980s came glass fiber reinforced composites, okay, Kevlar fiber reinforced composites, metal matrix composites, ceramic composites. So, these are all artificial composites. See, it took so much of time to learn about composites. That is what is the material cycle is. This picture is very important for every material science and engineering student, because this tells you the major material you use and how importance of these materials came over the 12,000 years time scale. That is what the civilization is actually. Civilization started about 5000 BC, we know that, for all these 4 important parts of the world, Mesopotamia, Egypt, Indus Valley and Yangtze Valley civilizations in China. So, we are very proud that Indus Valley civilizations were part of our civilizations in India and Pakistan. So, therefore, these civilizations have started with pottery, copper, bronze, everything. You can see that actually, that is very important. So, what is important is for you, we need new materials as you move along in the technological innovations. That is what you should be taking a take a message. To design a material, to give you a case study, very important case study. Okay? This is again taken from Michael Ashby's book. I am fond of Michael Ashby because he is one of the scientists who have made this design of materials as important things. Let us talk about it. How can you make a good device to open a cork bottle? Many times bottles contain liquids will be stopped by a cork stopper. How to remove it easily? Can I make a good remover? So, what is the need? A device that can allow you to access any liquid, here is written wine, any liquid actually contained in a corked bottle. That is what is your job. Okay, let us take some examples. So, first way is one can pull it up, you can pull using whatever devices you want in your home. Second is apply pressure. Third is apply pressure from the liquid, you can pull it up, what bottle can be upside down and apply pressure. Last is break, you can see here E, or you can actually explode, it can explode. None of these are actually good designs. Whether if you ask me carefully, none of these are good designs. These are all a person who is no knowledge of engineering can do that. That is not a design thing. One of the best way of designing is this, using what is called this screw. So, we can actually have a screw, we can push the screw into the cork and then pull it up, it will be removed, or you can actually remove this using this kind of devices. You have a plate, and the plate there are 2 knives, you can push this plate, along with the knife will be also pressed inside it and you can remove it. You can also press the knife at the middle, it will cut this cork into 2 pieces and remove it. These are working principles of implementing the first one of these first 3 schemes. Okay, remember, this is explosion, this is breakage, these are not at all choices, these are actually all accidents can happen. So, you see, these are how actually this kind of things has happened. This is the oldest one, the new one. There are different removal system. This is what you used extensively. One can also use this, other things are not so used in market now, but this is how the evolution of this design of this cork remover has happened over the time. So, one thing you understood in design, even the what is called agronomics as well as important things to understand is the how it look like. These 2 aspects are also considered. Design aspects has these 2 aspects also. So, you see that these are the 4 devices I am showing you how it is done. So, this cases tells you you can have a direct pull, you can have a levered pull, lever, this is a lever, you can see that, you can have a gear pull or you can have a spring assisted pull. There also you can make designs, you can see the gear pull, it is a very interesting design. Okay, you can have a simply gear, just by using gear screw you can remove this. So, it is basically screw, but screw can be pushed through by manually, all are manually, but this is just like a direct pull, this is like a lever, you can see there is a lever, less energy used, this is a screw. So, now that is okay, that is one part of design. Second thing example I will to show you is basically on a power electronics. All of you know that all the power electronics dissipate a lot of heat, large amount of heat is dissipated. If you when a computer or laptop is running, you can put your hand in there are fans in the laptop, hot air will come out. That means so much of heat is generated that has to be removed. So, when you have such huge amount of heat generated, what you need is a heat sink for the power electronics. It has to function like a heat sink, but it has some constants. it cannot go beyond 200 degree Celsius temperature. Why? Because all electronics die after 200 degree Celsius temperature. It should have very high electrical resistance, something like about 10 to the power 20 ohms, micro ohm centimeter, very high, and it should be thermally conducting. Obviously, why it should have a high electrical insulating? Because it should not conduct electricity at all, then it will affect your device performance. It should be good thermal conductor, that means it should have a very high thermal conductivity, something like 100 watt per meter Kelvin. It should not be heavy at all, it should be light, because your laptop is light, phone is light. So, it should have a density less than 3 mg or kilogram per meter cube, very small actually. And what are the free variables in the design? Material and processes. Material means what type material, and process how to make it. On the right side I am showing you, this is one of the kind of a geometry used. So, you can see there are a lot of cooling fins. This is where your fan is placed and air is blown. So, therefore, these fins get cooled down, and chip is placed on the top of this heat sink. So, that heat is transmitted from the chips to this kind of objects. So, as you can see, the function is a heat sink, it has constant, it must be good insulator, as I told you resistivity is very high, and all dimension must be specified, because computer has a geometry, right, geometry dimensions, and objective is to maximize the thermal conductivity, then only you can remove most of the heat. So, look at it, this is the service temperature plot versus different material. Metals, it can withstand very high temperature, steels, copper can withstand high temperature, lead and zinc, aluminum can use some medium temperatures, polymers can use only medium temperatures or low temperatures. Low means I mean to say room temperatures. Ceramics can go very high temperature, like tungsten carbide, alumina, it can, and composites obviously it can also go very high temperatures, depending on whether it is a glass fiber composites or ceramic fiber composites, it can go high temperatures. The 200 is your limit. So, you cannot use ceramics as well as composites. So, these are out. What you can use is basically metals, certain metals as well as polymers. Let us do the chart of thermal conductivity versus electroresistivity, it will be clear to you. So, you have told you have fixed electroresistivity to be 10 to the power 19, right, this is a 10 to the power 19 micro ohm centimeter, you can see that, and you also told lambda should be high, something about close to 100, in the range of hundreds of watt per meter Kelvin. So, what do we have? We have basically very limited, you can see almost all of them actually are metals, and if you want to have a light, ceramic is a choice, because they have lesser density than metals, but mostly it will be either copper alloys or aluminum alloys, because they are much above 100 watts, that is better, and compared to copper, aluminum is lighter. So, therefore, aluminum is better choice, and that is what is used as a fins material in these kind of things. So, you understand that this is how materials are designed for a specific application. I just wanted to give you these two examples in this story, so that you understand how a functional material can be designed, how a structural material can be, or like both the cases there is specific functions, whether it is a bottle or cork opener or whether it is basically heat sink. Both are very important examples in terms of applicability. They are really actually real examples which are used in the real case. So, I just wanted to stop here, so that you can take away message is that material design is a very important subject, and there are many applications where you need to design new materials, new processes, how we can use AI in accelerate the material design process, that is the key thing. So, I just started to show you how materials are designed traditionally. Now, slowly you will learn that you do not need to follow this traditional route anymore, but techniques will remain same. Techniques I mean to say the data handling, this is how all the data are plotted, right, in a thermal conductivity versus electricity, you can see all the data are plotted, but in a chart you do not need to do that. What you need to do is basically use a machine learning model which can predict you. So, let us stop here, we will come back to in the next lecture more about what are the things we can do in machine learning or design aspects of the materials. Thank you.